Let's solve some equations. So we've got 24 is equal to n plus 3. What we want to do is isolate n. So we'd like to eliminate the 3, and we can do that if we just subtract 3 from both sides. Notice that we start here with some variable, we add 3 to it, and that brings us up to 24. So let's subtract 3, but if we subtract 3, we need to subtract that from both sides. So let's do this. Like, take 24 minus 3 equals n plus 3 minus 3. In this first problem, I'm going to do every single step so that it's technically correct, but then we'll skip some of these steps in the next problems. So look at this part right here. That's 0. So what we're going to write is 24 minus 3 is 21 equals n plus 0, and n plus 0 is just n. So what we're going to conclude then is 21 is equal to n, or if you like, we can write n equals 21. Now this part right here, we're going to write, but we're not going to probably write this part right here. Let's try this one, 9x equals 18. Now what we have here is that the 9 is associated with the x by multiplication. So we're going to undo a multiplication with a division. So let's divide both sides by 9. That's going to look like this. 9x divided by 9 equals 18 divided by 9. Now again, let's write every step on this one. In this case, the 9's cancel, and we're left with a 1 here. So now we've got 1x equals 2, but 1 times x is just equal to x, so we'll write x equals 2. And here in problem number 3, we have x is being divided by 4. So what we'll do is undo the division with a multiplication. So let's multiply both sides by 4. It will look like this. 4 times x over 4 equals 4 times negative 7. These 4's cancel. That was the whole idea. And now we are left with x equals negative 28. All right, now what we've got is 6x minus 16 equals 34. So you might think about it this way. We start with some number, call it x, and here's what we did. We multiplied it by 6, then we subtracted 16, and that took us to 34, right? So we started with a number, multiplied by 6, subtracted 16, that took us to 34. So let's just undo what we just did. So we started with x, we multiplied by 6, we subtracted 16. So let's first of all add 16. So we'll get 6x minus 16 plus 16. But if I add 16 to that left side, I better do it to the right side. Now, this part right here is 0, but I'm not going to write the 0. I'm just going to go ahead and write what it's equal to. So it's going to be 6x equals 50. And now I'm going to undo this multiplication by dividing. Let's divide both sides by 6. So it'll look like this now. 6x divided by 6 equals 50 divided by 6. These 6's are going to cancel, and we will be left with x equals 50 over 6, but we can reduce that, right? They're both even, so we could divide both of these by 2, and that will give us that x equals 25 over 3. Now in this problem, we've got 7x plus 10 equals 45, so you can imagine what we did here. We started with some number x, multiplied it by 7, added 10, that took us to 45. So let's undo in that order. We'll undo the addition, then we'll undo the multiplication. Why don't you try it, and then pause the video, and then we'll come back and we'll do it together and see if we get the same thing. So first up, let's subtract 10. So we'll get 7x plus 10 minus 10 equals 45 minus 10. Those 10's go to 0, so we'll have 7x equals 45 minus 10 is 35. Now let's undo this multiplication with a division. So we'll get 7x divided by 7, 35 divided by 7. So we'll conclude that x is 5. So this problem here is pretty much like the ones we've just been doing. What are we going to do here? Two things in this order. We'll subtract 9, then we'll divide by 4. So let's do it. Let's subtract 9. We'll get 4x plus 9 minus 9 equals 33 minus 9. That gives us 0, so we'll get 4x equals, this is 24. Divide, I'm going to write this now, divide by 4. So I'm going to get x equals 6. Now up here, I could have written 4x over 4 equals 24 over 4, or I could just write this, or I can at least think this to get to this answer. But I want to show enough work so that somebody who's reading this can see logically where I started and where I ended. Now, notice that in number 7, we've got x's on both sides, so I need to choose a side. I want x's only on one side, and either side is going to work. The way I typically like to do these is I like to choose the side on which I have more x's already. Now, on the left side, I've got 4. On the right side, I have more. I have 6. So I think what I'm going to try to do is get all the x's from the left to the right. Now, that's not too hard to do. What I see here is that I've got 4 x's, positive 4 x's. So I'm going to subtract 4 x's. Let's show this. It'll be 4x minus 8, and then I'm going to subtract 4x from the left side. But if I subtract it from the left side, I have to subtract it also from the right side. And then this 4x minus 4x, that goes to 0, and we're left with negative 8 equals 12. And what about this part right here? 6x's minus 4x's, 2x's. Now we have the x's all on the right side. Let's get rid of the 12, and then we'll get rid of the 2. So let's eliminate the 12. It's being added, right? It's positive 12. Let's subtract 12. So it will be negative 8 minus 12 equals 12 plus 2x minus 12. That 12 minus 12 goes to 0. And negative 8 minus 12, there's a negative 20, equals 2x. What are we going to do now to eliminate that 2? We're going to divide by 2. So let's do it. Let's just do it. Negative 20 divided by 2 is negative 10. And 2x divided by 2 is just equal to x. There we go. So we're saying negative 10 is our x, or if you like, you can say x is negative 10. Now we're complicating the problems just a little bit more in that we have a multiplication over here. But let's use the distributive property. Distribute through with that 3. So multiplying through, here we'll get 3x plus 9. This is equal to 11x minus 19. Now, we've got x's on both sides, left side and right side. We've got more x's on the right side. I think I'm going to get all the x's on the right side. So let's eliminate these by subtracting them, right? There's positive 3x's, so let's subtract them. So here's how I'm going to write this. I could write, the 3x plus 9 minus 3x, right? We could write 3x plus 9 minus 3x and then minus 3x over here. But I'm just going to say what I'm doing by writing this. Here's what I'm going to do. I'm going to tell the reader I'm going to subtract 3x. Now, let's just do this. 3x minus 3x is 0, so that is gone. So we'll end up with a 9 on the left side. And then on the right side, 11x's minus 3x's, there's 8x's minus 19. And now we're getting close. I need to remove the 19 and the 8. So let's write minus, let's add 19. So I'm going to say what I'm going to do. I'm going to do this. I'm going to add 19. Let's do it. 9 plus 19 is 28 equals 8x. And then we're going to divide by 8. So we're going to get 28 over 8 equals, now 8x divided by 8 is x. I think we can reduce this. X is equal to divide each by, well, we could divide by 2, giving 14 over 4, but we could divide by 2 again, given 7 over 2. Now we've got an equation that involves fractions. What we could do is we could get a common denominator and combine these together, or a better way, I think, that works more generally is this. Let's get the LCD, the least common denominator here. What we're looking for is what is the smallest number that 4 and 10 divide into. So the smallest number that 4 and 10 divide into, I'll call it the LCD, least common denominator, is 20. Does that make sense? 4 goes into 20 and 10 goes into 20, and 20 is the smallest number that both of these divide into. Now if you wanted to use 4 times 10 is 40, that's fine, it'll still work, the numbers just get a little bit bigger. Now what we're going to do is we're going to take this 20 and multiply both sides of the equation by 20. I'm going to multiply it here, I'll multiply it by here. It'll look like this, 20 times v over 4 minus v over 10. This is equal to 20 times 1 over 4. Now, what we'll do is distribute the 20 to the first term, then to the second term. That's going to look like this. I'm going to distribute it here and then over here. So it will look like this. 20 times v over 4 minus 20 times v over 10 equals 20 times 1 over 4. Now notice something at this point. I got the LCD being 20, and where does that 20 end up? When I multiply both sides, the 20, the LCD ends up right here, and right here. The LCD ends up in front of every original term. So from now on, I'm going to skip this step because I know what the LCD does. It ends up right next to every one of the originals. So I'd write LCD equals 20, and then I'll write the 20 here, the 20 here, and the 20 here. I'm going to go directly from now on to this step when I have fractions. Now here's what happens. In this first term here, the 4 goes into 25 times, and we're going to get 5 times v, or 5v. Now in the second term here, 10 will go into 20, right? 10 will go into negative 20 2 times, so I'll get negative 2 there. So what I'm going to have then is negative 2v, and this is all equal to, now this 4 will go into 25 times, and then we're left here with 5 times 1, just a 5. We have taken this original equation up here with fractions and reduced it to one that looks a little bit simpler, no fractions. Let's just finish this up. 5v minus 2v is 3v equals 5, and now we're going to divide by 3, giving us v equals 5/3. Let's get a little bit of practice with this idea. So here's another problem that involves fractions. So what I want to do is, first of all, get the LCD. What is the smallest number 4, 6, and 12 will all divide into? So I'm going to write here that the LCD is 12 because 4 goes into 12, 6 goes into 12, and 12 goes into 12. And I think 12 is the smallest that all of them divide into. Now, I'm going to write this 12 in front of every original term. Here, here, and here. And doing so is going to look like this. 12 times 3x over 4 plus 12 times 7x over 6 equals 12 times 5 over 12. Now all these denominators should cancel. 4 goes into 12 3 times, and look what we've got then. We have 3 times 3x, right? 3 times 3x, that'll give us 9x plus, and then here, this 6 will divide into 12 twice, giving us 2 times 7x. 2 times 7 is 14, so we'll get 14x equals, now over here, 12 will go into 12 once, and we get 1 times 5, which is 5. Now adding these together, we'll get 23x equals 5, and now we're going to divide by 23, so we're going to have x equals 5 over 23. Let's give this number 10 a try, and we'll start this by distributing the 8 and the negative 7. So let's do that. Here's what we're going to get here. We're going to get 8x minus 32, right? Do you agree? 8x. Positive 8 times negative 4 is negative 32. Then negative 7x minus 14, right? Negative 7 times x is negative 7x. Negative 7 times 2 is negative 14, plus 22. Now we can tidy up the right side a little bit. We can add these two together. So we're going to get 8x minus 32 equals negative 7x. Now the difference here, negative 14 plus 22 is a positive 8. Now we have x's on both sides, left side and the right side. But I've got more x's on the left side, right? I've got 8 of them over here. Down here, over here, I'm down 7. So I've got more x's over here. I'm going to get all the x's on the left side. So let's eliminate these. It's minus 7x, so we should add 7x. So I'm going to add 7x, so we will get, now let's just do this. 8x plus 7x, that's 15 x's, and then minus 32 equals, and then negative 7x, add 7x, we're at 0, that goes out, and we're just left with that 8. Now we're going to do two things. Do you see what they are? Can you tell what they are and in what order? To isolate x, we're going to add 32, then we're going to divide by 15. So let's do that. Let's add 32, so we'll get 15x, and then minus 32 plus 32 is 0, and then 8 plus 32 is a 40, and then let's divide by 15. So x divided by 15 is x equals 40 over 15. We can reduce that, right? 5 will divide each of those numbers, so we're going to get x equals 8 over 3. This problem is similar to the last one we did, number 10. Let's multiply through using the distributive property. We get 3b minus 9 minus 3 equals, and then on the right side, how about 4b and then minus 24. And I've got b's on both sides. I think I'm going to get all the b's on the right side. I've got 3 on the left, 4 on the right. So I'm going to get all the b's on the right side. But before I do that, let's combine these two numbers here. So we're going to get 3b minus 12 equals 4b minus 24. So let's get the 3b on the right side by subtracting 3b. And doing so is going to give us 3b minus 3b. Those b's are gone. We get negative 12 equals, and then 4b minus 3b leaves us with a b, and then a minus 24. One more step. Let's just add that 24. So what we're going to do here is we're going to add 24. So when a negative 12 plus 24 gives us positive 12. And over here, negative 24 plus 24 gives us a 0, so we just get the b. So there we go. What is b? b is 12, or if you like, b is 12. In this problem, what we're going to do here is just translate this English sentence to words. So we've got 5 times what number equals 15. So first of all, why don't we do this? Let's introduce a variable here for the number. Why don't we say, let x equal the number. That's a good start. Now, typically when you translate these, if you just write what you read, you've got it. So this says 5 times, I'm going to multiply 5 times what number? Well, we're letting the number be x. So 5 times what number? That looks like 5x, keep going, equals, there's our equals, and then 15. So I'm just writing what I read. 5x equals 15. And now that's all we're supposed to do. We could, of course, solve this. Dividing by 5, we get 3. But all we're supposed to do is just try to translate this sentence into a symbolic mathematical sentence. Now we're going to not only translate, but we're going to use our skills to actually find the number. So let's translate first. Here's what we have. A number is increased, my abbreviation for increased, a number is increased by 70. And that result is 320. So let's start here. We need to always start by introducing a variable. So how about x or n or any letter you like? Let x equal the number. And now I'm going to read and pretty much write what I read. It says a number is increased by 70. So I'm going to start with the number. I'm going to increase it by 70. So to me, that means I'm going to add 70. And then is equal to, that's an equal sign, 320. Okay, there's our equation. So we've got the equation. Now what we're going to do is solve this. So we're going to subtract 70, right? 70 plus 70, let's subtract 70. So we will get x equals, now 320 minus 70 is 250. So when we write our solution, we're going to just write it this way, 250, and here's why. The problem says find the number. Now, find the number. I'm claiming that the number is 250. If you say find the number, you don't answer x equals 250, right? Somebody says, how old are you? You don't say x equals some number. So find the number. Just x is something that we use for our own convenience. Answer the question. Number is 250. Now again, what we want to do is write just an equation here. It doesn't ask us to find the number. But what we need here is this. Okay, 6 less than 8 times a number. We need the number. Now here's something we're going to see a lot. You see this phrase here, less than? We're going to see this quite a bit. So if you see something like less than, and then something, more than, something, or from, if you see these, whenever you see these, whatever follows it, that's where you start. That's the starting point. Less than this, more than this, that's where you start. From this, start here. So like you might say, I'm going from home to school. So where would you start? From home to school, you start at home. So when you see less than, start here. More than, start here. From, start here. So up here, we've got less than. We're going to start where? We're going to start here. 8 times a number. So we are letting our number be n, right? N is the number, and 8 times that number, we're going to write like this. 8n, but then we have 6 less than that. So we're going to write 8n minus 6. And then is equal to, there's our equal sign. Well, there's our equal sign. Is equal to that number added to 1. So we're going to take our number, n, and add it to 1. So how about take our 1 and then add our number to it? There it is. There's our translation. Now what we're doing in this problem is just what we've been doing before, but now we've got some decimals to work with. So how about if we start here? Let's multiply through using the distributive property. So this will give us 0.13n plus, now this looks like a calculator problem to me. I'm going to get 0.06 times 2450, and that gave me 147. So 147 and then minus 0.06n, and that's equal to, now 0.08 times that 2450, and that gives me 196. And now here, 13 minus 6, that's going to be 7, but I've got 0.13 minus 0.06, that's going to be 0.07. Do it on your calculator if you like. N plus 147 equals 196. And then 196 minus 147 is 0.49. And now we are going to divide by 0.07. So dividing by 0.07 on the left side, which is 0.07 divided by 0.07 is 1, so we just get n equals, now maybe on your calculator, or you can maybe do this one in your head, you're going to get 49 divided by 0.07. That turns out to be 7, right? 49 divided by 7, but you've got a couple of decimal places you have to account for. Turns out that that is 700.